Hello, thanks for joining us. We're going to wait about 1 minute here and then we'll get started with our content for today. All right, let's get started. So today we're going to be talking about how GrabCAD Print Pro can improve our efficiency, save us time, and give us better quality parts with higher accuracy. My name is Perry Hubling. I'm a senior project engineer with Stratasys, and I work specifically with the parts provider segment. And I'm going to be showing you around a little bit of what we can do with GrabCAD Print Pro today. One quick note, if you're watching this webinar live, we do have the Q&A box open. So if you have any questions during the webinar, please type them into the Q&A box and we will write back a response. So this is our agenda for today. First thing, we're going to talk for just a couple of minutes about what the existing free version of GrabCAD Print can do. Then we're going to get into the Pro features. So the Pro features, we're going to show demonstrations of the per part estimation, thickness analysis, part labeling, manufacturing templates, assemblies and positioning tools, the Accuracy Center. Then we'll talk briefly about the third-party plugins that are available in GrabCAD Print Pro. And then we're going to do a demonstration of the nesting features for the Stratasys SAF H350 machine. And then this last one, the support generation for Origin 1, this is actually not a Pro feature. This is available in the free version of GrabCAD Print. But it's an interesting new feature, and I thought it would be a good place to demo it here today. If you're not already a user of GrabCAD Print, I want to just take 1 minute to talk about the original free version of GrabCAD Print that anyone can download. What GrabCAD Print is able to do is it's a build processing software that works with Stratasys FDM, Stratasys SAF, Stratasys PolyJet, and the Stratasys Origin P3 digital light processing printers. One software can send jobs to all 4 of these different types of systems. It can also import CAD files directly. So you can drag and drop SolidWorks files or Pro-E files or any type of the more common CAD softwares. You can just drag your files directly into GrabCAD Print and print directly off of those. It can also do STL file repair, so you don't need to have a separate software for that. And GrabCAD is also a cloud-enabled software, so it can actually report printer data to a cloud server, and you can view that data. You can see the printer statuses, you can see the printer schedules, you can see printer histories, and also some reports based off those histories in the web app. So the picture on the left is the main interface for the GrabCAD Print app that you'd have on your desktop. So this is where you'd place parts on the build platform where you want to print them, and then this software will actually do all of the slicing, all of the tool pathing, generating supports, all of that, and send the job directly to the printer. So in the past, we had to have two separate softwares, like for FDM, for example. We had Insight for processing the tool paths, and then we had Control Center for actually managing the jobs as we're sending them to the printer. Now we've combined that all into one single app that can do both of those things. And then on the right side, you can see we have the machine schedule. So this is compatible with all of the Stratasys printers. So you can see if you have PolyJet printers and Origin printers and FDM printers, and a SAF printer, you'd see all of those schedules all at the same time on one interface. And you can see that machine schedule either through the app, or I've actually pulled it up here on the web browser, and I'm looking at it through the web browser. So you can pull it up on your phone or any web browser. You can go into the GrabCAD website and log into your account, and you'll be able to see your printers. So this is the Reports tab from the GrabCAD web interface. On the left side of the screen here we have the utilization graph. So this is just showing how much printing each of our machines is doing per day. And I can filter this by just look at one printer, or I can look at a set of printers, or I can look at all of the printers that are connected to this account, and I can filter for any date range that I want to see, and it will show you instantly that utilization. So this is really useful if you have printers in multiple facilities. You can actually connect printers from different facilities, even from different countries, all connected to the same account, and they'll give you this overhead view of all the printers overlaid over the top of each other. And this is really useful for operational efficiency, to make sure that you're getting the most out of each of your printers. If you're seeing that certain printers are not running as much as others, you can load balance between them and make sure that you're getting the best that you can out of your equipment. So on the right side of the screen we have the history report tab. So this will show all the jobs that were built on the printers that we selected to look at, and like I said, you can look at one printer or all the printers and any date range that you want. And the cool part about this is you can actually export this into an Excel spreadsheet. And then of course once you have that report open in Excel, you can search for anything that you want. You can search for specific parts, you can search for you can filter just to look at certain users that were sending parts to the machines. You can see all of the successes and failures and errors, and print hours and print material usages for both model and support. And you can filter for any of that you want in Excel. So like I said, all of that is available in the existing free version of GrabCAD Print that anybody can go and download. Now we're going to talk about what separates the free version from GrabCAD Print Pro. So here on this screen you can see this breakdown of the added features that we get in GrabCAD Print Pro, and as of right now the added Pro features are for FDM and SAF only. We will be continuing to develop this, so there might be Pro features for the other systems as well, and of course we're going to keep updating the original free version of GrabCAD Print. That's not going anywhere. That's still getting regular updates, and it's still going to keep getting product development. So this first tool we're going to talk about is a per part estimation. So in the past, if you were quoting parts and needed to know what the runtime and material consumption were for parts from different customers, you'd have to process them individually, because GrabCAD Print would only give you the total runtime and consumption for the entire tray of parts. So if you need to know what an individual part is, you can only have that part on the platform when you did the estimate. Now we can batch process those, so it's a huge time saver, just being able to do all of these at once. So let's say that I have this tray of parts here that's for either different departments and I need to allocate the cost to them, or if I'm a service bureau, I'm quoting these parts to different customers. So on this left side here, we have 5 of these parts. In the back here, I have this array created of 15 parts. And that's important because since I created these as an array, GrabCAD will treat these 15 parts in the back as one when it does the estimate. These 2 big parts in the center here, I'm actually going to group these together. Let's say that I'm always going to be building these parts as pairs, and I want to know the time to build 2 of them rather than building them individually, because there's a little bit of a time savings building parts together. So I'm actually going to right click and I'm going to click assemble. So now these 2 parts have been added to an assembly, and it's going to quote them together. So I'm going to hit the estimate button, and it's going to process this entire pack of parts. So this is the same estimation that the normal version of GrabCAD Print will give us. This is the total runtime and the total consumption to build the entire tray at the same time. Now if we go to the Build Reports tab, now it'll break it out into each individual part. And remember, I had those 15 little parts in the back of the tray that were arrayed together. This consumption here is for those 15 parts together. Same thing with this assembly down here. This was these 2 parts that I grouped together into assembly on the bottom. This part above it, these 5 parts were the large parts that were on the left side of the platform. This is the individual consumption for those 5 parts, so it's 1 of each. Now here's the really cool part. We can go up here and we can export this as an Excel file. Now when we open this, it'll give us the same 2 tabs. If we go to the Build Reports tab, now we actually get individual runtimes for these parts. So for quoting, either as a service bureau, or if we just need to allocate the cost to an individual department, now we can copy and paste this data right from this Excel spreadsheet. So let's look at the thickness analysis tool, which is a new feature for GrabCAD Print Pro. So I've got this electronic enclosure that I want to print. And I'm going to go up here to the Model Repair tab. See, we have no issues with our STL file. It's a good mesh. Now we'll go to the thickness analysis and we'll check it out in there. So I want to build this part in a 10,007 inch slice thickness in FDM. And general rule of thumb is you want to have about 3 times your slice thickness. So I'm going to set my thickness analysis to 30,007 inch and we'll hit analyze. All right, our analysis is good. Now let's take a pan around this part and we'll see if we can find any thin spots. So immediately I see at the bottom of these holes here, I have a thin spot. So it looks like what happened is when the engineer made these bosses on the inside here, they extended the hole too far towards the bottom of the part. It's creating a thin spot down there. So let's see how thin that actually is. I can grab the cursor here and I can reduce it. And when I get below about 5,000ths of an inch, it turns from green to red. So that means that the bottom of this hole here in this boss is actually only about 5,000ths of an inch thick. We can also drag our cursor around the part and it will show us a live view of the thickness. Yeah, about 5,000ths of an inch right at the bottom of that hole. So this model has an issue that we need to address back to the engineer that designed it. So now let's look at how we can use this on a whole pack of parts. All right, so we got a whole tray of parts here that we need to build, and we're going to check all of these at the same time. So what we're going to do is select all the parts on the tray, go to the model analysis, go to thickness analysis, then we'll hit analyze. All right, we've got our analysis complete. And a really nice feature that you can use this for is actually determine what slice thickness you need to use for your tray of parts. So I can actually grab the slider here and I'll drag it to the right until I start finding some thin spots. All right, looks like most of the parts on our tray, we've got at least 40,000ths of an inch. Once we get up to about 40,000ths of an inch though, this part here on the right, we start getting some red spots. So we've got a wall on this part that's about 40,000ths of an inch. The rest of these parts on the tray are all pretty thick. So I could build the rest of these parts in like a 13,000ths inch slice thickness. That would give us about a minimum wall thickness that we want to get to of about 45,000ths of an inch. So this part on the right here, I might want to take this off and build it on a separate tray or a different machine at a 10,000ths inch slice thickness. The rest of these parts we could all build at a 13,000ths inch slice thickness. All right, now I'm going to demonstrate the labeling feature that we have in GrabCAD Print Pro. What this will do is it allows you to either emboss or deboss lettering or numbers, alphanumerical characters into the surface of your STL file. So I have these 4 parts here. This is a manufacturing fixture, so a part fits onto this part, and then some drill bushings get pressed into here to allow them to drill a hole and then tap the hole. The customer wants me to serialize these parts, and they also want me to mark them with the manufacturing date. So I'm going to go to the top view here. I'm just going to label these top 2 up at the top. Right click on the part that I want to label, and I'll go down to add label to body. And then it will allow me to select the location where I want to put the label. And then I can type in whatever I want into here. But to save some time, I've built a couple templates so I can quickly label a whole bunch of parts. So this first template I have here is a numbering template. So we're going to start at 1,000, and this will numerically increase each label by 1 number. So I'm going to apply that to the first part. Now I'm going to go to the second part, add label to body. Now I'll go back to my template and select that, and we'll automatically go to 1001. Now you'll see here up at the top of the screen it says model geometry is out of date. We need to click that button, and it will apply our lettering to the surface of the part. There. So now we have our serial number embossed in the part. Then we can use our other template here that I created for our manufacturing date. And this one doesn't have any counter or any change each time we apply it, so it'll just apply the same thing each time. So put that on the first part. That on the second part. There. And now we can do that to every part on a tray, and we do not have to go back into CAD or into any STL editing software. We don't have to make any CAD change at all. And we can process this and send to the machine to print. Now let's use the same part to set up a manufacturing template. What a manufacturing template does is it takes all the settings that you input into GrabCAD Print and it exports them into a file that you can either use later or send to somebody else. So if you need to build iterations of the same type of part over and over with the same settings, this will save you a ton of time setting up your builds. And it's also great if you're building parts at different facilities that you can share these templates back and forth and make sure that you get consistent results. So let's say that this customer wants me to build this part in polycarbonate. (13 thousandths of an inch slice thickness). And they've specified that they want sparse infill with a certain infill density and a certain body thickness. And then I know from experience that I want to use smart supports for this part. So now we can export this as a manufacturing template. So this window that opens will show you all the settings that it's going to save as part of the template. Name it. And now I'll go up to here to File, Open Project. Find my file that I just created. Add a model back to the tray. And now up here in the upper left, we get this message restricted project. That means we're using the manufacturing template, and it will lock out all the settings that we had set previously. So now everything will be set exactly the same until we open a new project, and then it will reset back to the default. Here's another trick we can do in GrabCAD Print Pro. So I'm trying to build these dish-shaped parts, and even though they don't actually touch each other, GrabCAD won't let me print them together because their X and Y extents overlap each other, and neither GrabCAD Print nor Control Center will allow you to print parts that overlap in X and Y. So what we can actually do is select these parts, and we can put them into an assembly. And when we put them into an assembly, GrabCAD will treat them as if they're one part. So now up here we have these three parts are in an assembly. Then I can copy them. And I can paste that entire assembly. And you can see once they're in an assembly, GrabCAD treats them as if it's one part. So I move them all together at the same time. So now we have two assemblies that are overlapping each other, but we can actually click on the two of these and we can combine our assemblies into an assembly. And now if we hit estimate, now it'll generate a build for this. So now as you can see, we can print this assembly because GrabCAD is treating it as one part. And that allows us to fit 6 of these parts on the build tray instead of only 4. All right, let's talk about GrabCAD Print Accuracy Center. So the Accuracy Center is a tool within GrabCAD Print that we can use to correct for warpage in our models. So this actually works in a closed loop fashion. So we print the part, then we take a 3D scan of the part, and then we correct the model geometry to counteract that, the warpage that we're seeing in our 3D printed parts. So we're going to change gears here a little bit. Shivam Ghosh from Stratasys Software is going to be presenting this segment. One thing I did want to note is that since Shivam's presentation was made, where there's actually a new version of GrabCAD Accuracy Center that can do iterations. So we can actually print the part, scan it, make the corrected model, and print it again, and we can scan that again and keep correcting the accuracy until we get it perfect.
Hello, I'm Shivam Ghosh with Stratasys Software, and let's talk about taking your printed part accuracy to the next level. Before, you'd bring a CAD file into your slicer, print it, and you get what you get. Sort of an open loop concept, right? But now, what we're saying you can do is scan that part. The software will tell you what the scan looks like and automatically correct it, so your second print comes out a lot more accurate. But before you worry about us changing your CAD file, remember the whole goal is to be more faithful to the CAD, so we're actually trying to get what the original intent was from this printer. So how are we making your parts more accurate? Well, before Accuracy Center, when you'd print, there's a certain amount of random printer error, but a bigger amount of systematic printer error. Thermal effects, where it is in the tray, your geometry. But the interesting thing about that is it's not random. It's consistent, like wind on your T-shot. And if the wind is always blowing to the right, you can angle your T-shot to the left and correct for it. There's also post-processing error, which is mostly thermal effects, but that's also not random. That's also like wind on a T-shot. And then there's a little bit of scanner error itself. After Accuracy Center, there's still going to be the same amount of random printer error. We can't correct for that. But the 2 consistent errors we can correct for, like wind on a golf shot. Okay? Just angling it the other direction. There's still going to be the scanner uncertainty error, but interestingly enough, the better your scanner is, the tighter our algorithm gets at correcting for that error. So there is a limit on how bad your scan can be before this process isn't worth it, and we'll talk about that in 2 slides. Some quick numbers to ground us. Here are approximate errors for about a 6-inch part that fits in your hand. The total error could be plus or minus 385, 400 microns. After Accuracy Center, we can take that down to about plus or minus 85 microns, which is close to the theoretical limit of what that printer can do. You of course have to keep these errors repeatable, which means the same machine, same geometry, same material, same portion of the tray. As long as you keep all that consistent, then the algorithm can correct for wind on that golf shot. Here we are in GrabCAD Print. I'm going to drag in a part file that we've printed. It's a duct. We usually print it at Altem because it goes into the engine compartment of a car, high temperature, high chemical resistance. And then I'm going to pull in the scan of it. So I'm going to go to Accuracy Center, and we're going to go import the scan that our scanner put out. This is after we've printed the first time and scanned it, but before we've done any corrections. You have to select the units the scan was taken in, and then hit Compare. And we're going to fast forward through the 3 to 5 minutes it takes to align the millions of triangles from the scan to the CAD file. All right, the comparison's done, and what you can see is a lot of blue and red. Blue is where the printed part is too small compared to the CAD. Red is where it's too big. And if you look for where blue changes into red, those are the worst parts. That's like a sine wave deformation, right? Too small, too big, too small, a sine wave. And if you look up here at the top, you can see a big 29 for your print accuracy score. That's out of 100. 100 doesn't mean you have a perfect part with 0 deformation, but that's the 100 is the best this machine can do with this size of part based on our published specs. Okay, so 100 is what you're going for. 80 to 90 is a good strong A on an English paper, but 29 is pretty bad. We've also got a histogram down here, right? What you want is a bell curve centered around the white section of 0. What we've got instead are these huge towers of blue and red. Those are all the outliers that don't fit on the graph. So what we're going to do is take the automatic corrections that Print Pro gives you, print it again, and then bring in the scan of the second print. Okay, this is the after scan. We're going to do the same thing as before, choose millimeters and compare. I'm going to fast forward through the compare and analyze part where it's aligning millions of triangles again. And look what our second result is. A print accuracy score of 80, which is a lot better, right? That's a solid B on an English paper. You've also got a lot less blue and red. You've got gray, which is what you want. And down here in the histogram, you can see the nice bell curve. The previous results are in black outline. The current results are in color, red and blue. And you can see how much of a difference it is, right? This is the result you want for a tight printed model. I can even flip back and forth between the original 29 and the current 80. So you can see both results in one go. And here we go. Not only did you go from a print accuracy score of 29 to 80, you went from your worst dimension error being 2,800 microns too big to 188 microns too small. A huge improvement. That's because GrabCAD Print Pro automatically corrected your results from your scan in your first print to improve your second print. That's the type of results you can expect from Accuracy Center.
So another capability we have within GrabCAD Print Pro is we actually support third-party software plugins. So just like downloading an app onto your phone, we can work with third-party software developers, and they can develop software that we can integrate into GrabCAD Print Pro. So you have your GrabCAD Print Pro license, and then you can add these third-party developed softwares on top of it. So the first one we're going to talk about here is AlphaStar. So AlphaStar is a simulation software that actually analyzes the build toolpaths that you generate in GrabCAD Print, and it will give you feedback on the thermal stability and thermal buildup within the part as it's going to be building, and any gaps that might be present within the toolpath parameters. So it'll actually analyze that for you after you've processed the job in GrabCAD, and it'll give you feedback on any probabilities of success or failure. And then you can rectify those by changing the settings back in GrabCAD Print and try again. So it'll actually predict failures in a build before they actually happen. Another software that we support is called Caster. Caster is a software that helps organizations identify parts that are good candidates for additive manufacturing. So you can take a whole bunch of CAD files and dump them into this software, and it will sort through them and find the parts that are the best candidates for additive manufacturing that will save the most time and save the most money. And it will actually give you estimates in the software of how much money can be saved to 3D print these parts compared to their traditional manufacturing methods. And finally, we have integration with Cognitive Design Systems cognitive additive software. This software is designed to analyze a part, its manufacturability for additive manufacturing, and it gives you this report showing any potential issues with wall deformations and thermal concentrations, and advises on the most appropriate orientation to build part in, and it also analyzes the costs that are going to be involved with producing the part. Here I'm going to show a little demonstration of how GrabCAD Print Pro works with our H350 SAF machine. The SAF machine is a powder bed fusion machine, so it builds like a large vat of nylon powder. So in the past we actually had to have like a third-party software to do the nesting to pack all the parts into the build chamber, but now with GrabCAD Print Pro we can do all of that in one software. So we can do all of the nesting and the build processing and the time estimation all within a single software. So we have a big pack of parts here, and we're going to nest it together. We can select all of our nesting parameters that we want, and the software will automatically go through iterations of packing to find the most efficient packing scheme to get all of our parts in the build chamber. So it's going to keep running through iterations until we are happy with the result that it gives us, and then we can stop the iterations at any time and let it go with what it's come up with. So here's our completed pack of parts. So this is that's all the time that this took. This was played in real time, and now this is ready to send to the machine. Then of course we can also estimate the pack without having to actually send it to the machine. So I got 12 hours and 29 minutes for these 134 parts. And finally, I wanted to give a little demonstration of how the support generation works with our Origin P3 digital light processing printers. So this is not a GrabCAD Print Pro feature. You do not need to have the Pro license for this to work. All you need to have is Origin P3 printer, and the base free version of this software will work with this. I wanted to show it here because it's pretty cool. You can set up your tray settings for your printer. You select the type of resin that you want to use. You select the support styles that you want to support your parts with inside the printer. You can select the default support style for the tray, and then you can also go into the individual models and you can select one of the pre-programmed support styles for each individual model if you have more than one model on the tray. Now here we'll demonstrate how we generate the anchor points for our support columns. So we went through the automated anchor point generation, and we can easily edit any of these anchor points or add new anchor points. We just click on these points and drag them to where we want them to be, and then when we're happy with everything, the software will automatically generate the support towers to those points. This is, of course, just a very simplified and quick demonstration of how the support generation works. If you want to get into the weeds on it, of course, you have a ton of controls over how you want to generate the supports. But everything is done right here in GrabCAD Print. You don't have to go back and forth between different software packages. And when you're done, you can send the job right to the printer directly. All right, that's all the content that we have the time to cover today. So if you go to the GrabCAD Print website, you can fill out a form and you can download a 60-day free trial of the software. And if you have any questions, please reach out to us. Thank you for joining us today.